All right, so on Monday we talked about inheritance in well, we talked about S3. Okay, we introduced object-oriented programming. We talked about S3, and then we kind of had to cut it a little bit short, and so I modified my slides a little bit. And basically, I removed the slides on next method. Maybe I'll have like a deeper dive next method section, just optional for those of you who are curious about next method. But basically, I had to remove some of this stuff. Okay. And then there's this function S3 dispatch that comes from the sloop package, SLOOP, I should say. And it shows you how the methods get dispatched in R. And basically, if you have an object that has inherited classes from other things, R is going to search for the most specific version of the method and then look for more general versions of the method until it reaches kind of default. All right. So for example, we've created a factor, an ordered factor, okay? And we call print on it, okay? So when you call a factor with ordered true, it creates an object of class ordered. And so R searches for a function, a method called print.ordered, and it doesn't find it, it doesn't exist. So then it looks for a method called print.factor, and that exists and it uses it, okay? There is also a method or a function called print.default, but it doesn't get used, okay? And so, you can think of this as subclasses and superclasses. And then I set up a whole bunch of slides for your benefit, and this is going to be the method Dispatch SelfQuiz. I recommend that you go over this. I think I had like one method dispatch question on your quiz on Tuesday. You can definitely expect to see some of these types of questions show up on the midterm exams. So this is here to study, and so we can just do kind of the first one, and then from there I'll let you guys you can go through it. So basically you go through these slides, and then when you click next, it kind of presents the question, and the question, if you see a line of code without output, it's basically asking you, what is this going to output here, right? So here we've defined a function f, and it's a use method f, and so that's going to be a generic function f. We create a method f.j, we create a method f.k, and then we create an object called k with the value 1, okay? And so if I call f on k with the value 1, what is this function going to return? What do you guys think? Your choices are 3, 11, error, or nothing. Okay, everyone's too nervous to answer? It's class, right? You say the wrong answer, and the worst thing that happens is, the correct answer is something different. So what do you guys think? Nothing? Okay, the answer is it produces an error, okay? Okay, so it produces an error, and so this is what R is doing. It's searching for a function f.double, okay, because this number 1 is type double. It doesn't find it. And then it searches for a function f.numeric, doesn't find that. Searches for f.default, and it doesn't find that. And so it says, this is an error, okay? All right, here we create k is the value 1, and we assign j to the class of k, and then we call f on k, and what is this going to return? 3, okay? It returns 3, it prints out some extra junk, okay? And then basically what it does is it searches for f.j, it finds it, and so it executes that, okay? All right, so anyway, there's more of these questions here, and please take the time to go through it, especially as you guys study, okay? All right. Before I go on, are there any questions about S3 object-oriented stuff? We're all good, okay. All right, so R6, that's what we're going to talk about today, okay? The R6 object-oriented system. This is another object-oriented system in R. S3 is the more important one, okay? You got to learn S3, all right? And you're going to be tested on S3. Basically, everything in base R runs off of S3, okay? Everything in base R runs off of S3, and so it's important to learn in that regard. And you can do quite a bit with S3, okay? But I also want to cover R6, which I think is pretty neat. I'm going to assign a homework that's going to require you to use R6. I've got to finish tweaking the instructions there. And yeah, so anyway, so R6 uses what we call encapsulated object-oriented programming. This is going to be kind of the same object-oriented systems that exist in most other languages, okay? R6 objects are mutable, which means they are modified in place, and they have reference semantics, okay? And then the methods belong to the objects themselves. So to do this, you have to install the library R6, install.packages R6, and then you call library R6. All right, so let's talk classes and methods. You define a new class, a new object class in R6 with this function R6 class, okay? R6 class. This is the only function that you use from this library, okay? R6 class, all right? But then it comes with all of this stuff, all right? And basically, when you set up a function, you should give it at least these two arguments, right? Technically, you can get away with not supplying them, but pretty much most everything should have these two arguments, okay? Class name, okay? That's the name of the class that you are creating. By default, we capitalize them. If they're R6 classes, we capitalize, and using upper camel case, meaning if it's multiple words, you don't put spaces between them, you just capitalize the new words, okay? And then in public, you put in fields and methods, okay? This is a list. A list can contain objects of different type, and so you're going to put in values in your fields, you're going to put in functions as methods, and they all go in the same list, and that goes to public, okay? And then by default, we use snake case, which uses underscores to separate separate names. All right, so here is a very, very, very simple R6 class, okay? We use class name called accumulator, again, capital A, accumulator, and then it's important that when you create a new class, you give it the same name as your class name, right? So we're calling R6 class, the class name is accumulator, it needs to be saved into an object of the same name. Otherwise, you're going to run into problems. It's not going to produce an error, but you're going to run into some issues. Okay, and then public is a list. There's two things in this list. The first is sum, which has the value 0. It's just a numeric value with the value 0. And then add is a function, so this is going to be a method. Okay, and notice what this function does. Basically, we're going to add values to itself. It's an accumulator, so we have the function. It's a function of x, takes on the default value 1. And what this does is it takes the value of sum, it adds x to it, and it stores it back to sum. But notice how it accesses the value sum. It accesses it using self $sum, okay? So these things are technically stored inside an environment, but we're going to take the value that currently exists inside whatever object we create. So we create an object, it's going to have the value sum, and to access that value, we use self $sum. So we're going to say self $sum plus x, and we store that back to self $sum. All right, is that okay? To access the values from inside the object, you use the self and $. Okay, and then the function itself, the function returns, the last line of a function is what it returns. It returns self inside invisible. Okay, and I'll talk about what that means. Okay, so this method takes sum, adds x, stores it back to the sum value inside self, and then it returns self invisibly. Okay, And so when you just ask, well, what is this accumulator object that I've just created here? It says, okay, it's an object generator. Inside public, we have the field sum, and then we have the method add, which is a function here, okay? All R6 objects, when you create them, will also come with other methods, such as clone and new and stuff like that, okay? And so this is what we have, all right? All right, and so let's just show how this works, right? So here I'm going to say accumulator $new, okay? So all R6 objects, or R6 classes, when you create them and define them, they're going to have a method $new, okay? And this will create a new instance of accumulator, okay? And so here, if I ask, well, what is X? It's going to say X is an accumulator, and inside public, we have the function add, and we have the sum 0. There's also a function clone. And then, and we can access values and methods with the $sign. So we can access that value of sum, and we can call X $sum, and we get 0. All right. And then so to use it, I can do X $sum, we have 0. If I call X $add, this calls the add method. And notice it doesn't output anything to the screen, okay? But you know, inside the definition, it's running this thing. It's doing add with the default value 1, and it's going to do sum plus X stored back to sum. And so if I ask, what is X $sum now? It says it's 1. Here I do X $add 3, and then the sum is now 4. Okay, so this is just using this class that I've created. All right, let's just take a closer look at this thing. This invisible self, okay, what that means is it's returning the object, the object itself, okay? And so when we run the add method, the result of the add method is also the object itself. The invisible part says, don't print it out, okay? So normally you'll write a function, the last line is like, you know, inside your function you're calculating results or something, and the last line is the result. And then, and when you run that function, it generally prints out the result. Here, when you say invisible, it returns a value, but it returns it invisibly. So you could like capture it and assign the value somewhere. In this case, we are returning the R6 accumulator object itself, okay? And so what this allows me to do is it allows me to chain methods, okay? So right now, X $sum is the value 4, and I could do X $add 10, okay? And this will call the method 10, which modifies the value sum, adds 10 to it, and gives back 14, okay? But the result of this is the object itself. It returns itself. So this itself is also going to be an R6 accumulator object, okay? Which means this object also has the method add, okay? And so I can call add $add 10 on this object itself, right? So you could pretend like I took this and I'm storing it as something, right? And we can call add 10 on this. And so here we call the method, and this itself will add 10 to the value 14, and this is the object itself. And so that means I can access the field with $sum, and so now I'm at 24. Right? Does that make sense? This idea of object chaining. Object chaining is like if you've worked with Python, you're probably familiar with object chaining. This is kind of a very central concept in working with objects in Python, and it exists in a lot of languages as well. So we've got object chaining, and it's possible by including invisible self as the value that the method returns, okay, as the object that the method returns. All right. You know, for readability, sometimes people recommend that you keep each line on or each command on its own line, okay? And so Here I do $, and then I do add 10 and add 10, and I call sum, or ask for the sum, and it goes from 24 to 44. So no surprise there. It's much like dplyr as far as style goes. Every time you use the pipe, you should go onto a new line to kind of break things up, right? You're not required to. R will still execute things even if they're all in one line, even if all of your pipes are all together. You're not required to go to the next line, but it's recommended. Okay, so some methods that we recommend creating are the initialize and print methods, okay? So every R6 object is going to have a new method that creates new instances of that class, okay? If you do something called initialize, if you create a method initialize, you can kind of do some validations to make sure that the input values are valid and things like that. And initialize will override the default behavior of new. Okay, so new just creates a new instance, doesn't do any kind of checks. And initialize will override it. So you still call $new, but it's going to use the function defined in initialize. So inside initialize, we're creating this person object, okay? So the person object comes with name and age, right? So inside public, we define name and age, and we define a function initialize, and initialize takes in the values name and age, okay? And it runs a few things, right? It has a stop if not, okay? So this is going to return an error, and basically everything in here has to be true, okay? So is.character name has to be true, length of name equal to 1 has to be true, okay? So basically it has to be a character vector of length 1. And then it's also going to return an error because it does a check on age. Is numeric age has to be true, length of age equals 1 has to be true, okay? And it's going to stop if either of these things are not true, if any of these things are not true, okay? And then if those are true, then we're going to take the value of name and assign it to self$name, and we're going to take the age that was provided in initialize to self$age, okay? So we're storing these values into the public list here. All right, is that okay? And so, so here I have person, okay, person defined here, and we are going to give it the name Hadley, and we provide the age 38, okay, written as in characters, okay. And so this produces an error because the initialize says it fails this check, right? Is.numeric age, that's false, so it produces an error, okay. And so, so here I try to create the person again. I do person $new, Hadley, age equals 38. It still runs the initialize function, and it says, okay, that's good, and it stores it into object Hadley here. Is that okay? Great. All right. And then the other thing is you're not required to, but this is also probably you want to do, is you want to create a print method, okay? So the print method, that's the default print method for R6 objects looks like this, okay? It's going to print out the class name, person, and then it says in the public fields we have age, and we have the functions clone and initialize, and we have name is Hadley, okay? So just kind of list these things off like this. Now you might say, well, I don't want it to print out this way, and so you can define your own print method, okay? So here we create an R6 class name is person, public is still this list, we have name and age, we have the initialize method from before, and now we have the print method, okay? The print method is a function, we give it, and we tell it to do this. It's going to cat the cat person with a new line, cat name, and then it retrieves self $name, and it also retrieves self $age, okay, and it cats that to the screen. Right. And so here I define a new person, okay, person $new, Hadley 38, and I assign this to object Hadley2, okay, Hadley2. Now when we print this out, prints out with the method that we've defined. name, Hadley, age 38, okay? So if it's not clear, I'm using, so this is all coming from Hadley's book, Advanced R, the second edition. It's very good, and I'm using his examples straight up, and I'm just kind of adding some text explanations in between here and there. All right, so is this okay? All right, one thing to note is that with R6, the methods are bound to the objects themselves, okay? So we have the object Hadley2, which is a person class object. We have the object Hadley, which is a person class object. But Hadley2 was created after we defined the person class object as having the print method. The first Hadley that we created earlier did not have the print method as part of its definition, okay? And so when we print out Hadley2, it uses the print method that exists, but when we print out Hadley, it doesn't have that print method associated with it, so it just prints out the default way, okay? This might be a little confusing, but it's not confusing to R, because R just looks at the object and says, these are the functions here, these are the functions or methods associated with this object, and it just uses them accordingly. They're actually stored inside R as environments. So when you like redefine the kind of the R6 class, it's not going to go back and change all of the previously defined objects of that class. Okay, it's just saying, okay, this is the new definition, and here we go. It's like, you know, each year they update the Honda Civic, and it's not like the old Honda Civic suddenly get new features as well. Okay, so this is just what happens, right? Okay, so as you are programming, and if you're like trying to create a class definition and you create some test objects along the way, just to avoid confusion for yourself, it's often recommended you delete the old objects that the objects that you've created under the old class definitions, just so you don't confuse yourself. Okay, but again, R is not going to get confused because it just looks inside the object and says, okay, these are the methods that are available to me, right? All right, another thing that's available, and I don't know if this is best practice, but another thing that's available is you can add methods to a class that's already been defined, okay, using the set method, right? So here we've got accumulator. We created accumulator. It's got no public fields. It's just got the class name, and then we are kind of setting these kind of after the fact, okay? So we're going to say set public. We give it sum. We give it the field name sum with the value 0, and then we say set public, and we give it the name add, and that's going to be a method because it's a function. Okay, and again, when you do this, when you use set or you modify the definition, it just changes the definition for future objects, and it's not going to change anything that has been created in the past. Okay, let's talk about this topic of inheritance. Okay, so an important idea for any object-oriented system is inheritance. And so inheritance is the idea that a new class inherits from a parent class. Okay, so you've got the parent class and you've got the child class, or I guess the superclass and the subclass. Okay, and so in this case, we are going to create a new class called accumulator chatty. Okay, so remember the accumulator is just this very simple R6 class where it's got sum and it has one method, add. Okay, and so accumulator chatty is kind of like the verbose version of the accumulator, and we're going to say this thing inherits from accumulator. Okay, it inherits from accumulator, and look at the list that we provide to public. The list that we provide to public only has one value in it. It only has the method for add. Okay, so anything that we don't put in here, everything else just gets inherited, and then things with the same name will kind of overwrite the ones in the parent class. So the value sum is a field, and that gets inherited from the parent class of accumulator. Okay. All right, and so here we have a method add, and this is going to overwrite the add function in the superclass. And notice what it does. It says add is going to be a function of x, and we have this line that says cat adding x. Okay, so basically it's just outputting some stuff onto the screen. And then it's going to want to do the same thing that it did before, which is going to take kind of $sum, add x to it, and store it back to $sum. Okay, but rather than writing out all of that stuff, $sum, arrow, $sum plus x, and then return invisible self. Okay, rather than doing that, we just call super $add x equals x. Okay, so we are calling the original, or the original add method in the parent class or the superclass. Okay, and even if the original method is like very short and only like 2 lines of code or whatever, it's recommended that if you want to basically perform the same action, you should just call the the method in the superclass. Okay, and the reason for this, right, is because again, I could have just taken the original method, that $sum, arrow $sum plus x, and I could have just copied and pasted it down into here, right? But as programmers, anytime we're dealing with functions, is we want to avoid copying and pasting. The whole idea of functions is that you don't copy and paste, but you're referring these functions, so that even if you have perfectly good code, if you copy and paste it, and later on you decide to make a small tweak, you're going to have to copy and paste that tweak everywhere else that you've copied it, right? By referencing super $add, if I ever make a tweak to the original add method in this superclass, it's going to take place down here as well, okay? And I don't have to worry about like copying and pasting those changes. So we refer to the original add method or any method in the superclass by using super $method name, okay? So does that kind of make sense here? And so now the accumulator chatty, I create a new instance of this. This is x2, and then we can do x2 $add 10, and again we've got method chaining x $add 1, and then sum, and then so it cats out adding 10, adding 1, and then we get this final value of 11. Okay. All right. Okay. And so this is just this slide just explains in text what I've been telling you guys about this. Okay. When you ask for the class of an object, okay, an R6 object, it's going to give you the class name and then R6. Okay. So everything inherits from the kind of master parent R6 object, which contains the methods like new and clone and I don't know what other stuff, right? Set. So there's certain methods that we've been using, and it inherits them all from the R6, but it shows this, right? So here, the accumulator chatty objects inherits from accumulator, which inherits from R6. Hadley and Hadley 2 are both person class, but we have to remember that this person class definition is different from this person class, right? This one we added the print method, this one doesn't have that, okay? And there's no indication here that tells you that they're different, right? They're just known as person class objects. R has no problem remembering, okay? Because they're entirely different objects. And so if you want to see what methods we have, you can call names on the object. So names Hadley doesn't have print, whereas names Hadley 2 does, right? So we have age, name, clone, initialize, but this one also has print. When we look at this one, which is the chatty accumulator, we've got the sum and the add as well as clone and enclosing environment stuff. Okay. All right, so an important thing to note is that R6 uses what we call reference class semantics, okay? Reference semantics. All right, so most of R, so if you've gotten used to R, the way R works, R uses what we call copy on modified, okay? Which means when you modify an object, it creates a copy of it and that's what you have, okay? And then, you know, and then there's like a garbage collector to kind of clear out memory and stuff. So here, what's happening here is we have this vector 1, 2, and we bind the name A to it, okay? A gets bound to this vector 1, 2. Then we do B arrow A, and so this is going to bind the name B to this object A, the same object A, okay? And then here I do, I modify B, okay? I do B1, take the first value in B, add 10, and store it back to B1, okay? Now, this action here, R doesn't show any of this, but what happens is R says, oh, we are modifying the first value of B. So what it does is it creates a copy, right? So B and A are currently, at this step, B and A are pointing to the same thing, but then when it says, oh, we are modifying B, it creates a copy of B, or yeah, creates a copy, modifies the copy, and saves it, okay? So therefore, A remains unaffected with the values 1, 2, and B has the values 11 and 2, okay? And so this is not surprising. This is just how R behaves, right? I think we're accustomed to this. All right. R6 objects use reference semantics, okay? So here, I create a new instance of an accumulator, okay? And I call this X. Then I bind the name Y to this object X as well, okay? So X gets bound to a new accumulator object. Y gets bound, the name Y gets bound to the X object, okay? And then I call add on the object Y. So I do Y add 10, okay? But notice what happens. The value in X $sum is 10, and Y $sum is also 10, okay? So what's going on there is the name Y is pointing to the exact same object that the name X is pointing to, okay? They're both looking at the same, they're both talking about the same thing. So when we say modify Y, okay, it's modifying the same exact object that X is pointing to, okay? So Y and X are basically like aliases. They're the exact same object, but we just have two names for the exact same object here, okay? And so this is something that we have to keep in mind. And if you're expecting copy on modify semantics, you're going to be surprised with reference semantics, okay? So just keep this in mind, right? So if you wanted to say, well, you know, I want a thing, like I want a copy of X, but not actually the same thing, you have to use the clone method, okay? So here I create a new instance of X, and then I can do X $clone here and call this Y, okay? And so now when I call add 10 to Y, it's a different method, right? Or it's a different object. So Y is pointing to a copy, and X is pointing to kind of this original thing. So here I add 10 to Y. The original value, the value of sum in the original X is still 0, whereas the value of sum in Y is now 10. Okay, so this is done by using calling the clone method. Right. So reference semantics can be tricky. In regular old R, when you see code like this and you call a function on X and Y, we know that it's only going to change the value Z. We know X and Y are going to be unchanged. Okay, but with reference semantics, if X and Y are reference class objects, so this shouldn't say list, it should say something different. When you call a function on an object, you might not be sure if it's modifying the function itself, or modifying the object itself, or if it's just returning a value. Okay, and so this can become tricky. So the recommendation is that when you have a function that interacts with R6 objects, okay, they should either return a value but not modify the input R6 object, or they modify the input R6 object but don't return a value. But they shouldn't do both, okay? If they do both, you can run into some slightly confusing situations. Now, there's no rule against it, and there might be real legitimate situations where you want to do both, where you want to return a value and modify the original object, okay? And there are situations for that, but in general, just to avoid confusion, we recommend pick one or the other. Either modify the object, don't return a value, or return a value and don't modify the object. Okay, so here I give you two examples, two functions, one that modifies it and one that returns but doesn't modify. Okay, so here is the kind of, again, we create a new instance of the accumulator, and here I create a function that calls the method add5 on the whatever accumulator object that we provided. And so in this case, this will modify the values inside x. So when I run the function add5 to sum of x, then x sum gets modified to 5. So the change of x sum being 0 to changing to 5 happens in this line. Okay. Whereas in this function, we retrieve the value sum, we multiply it by 10, and this is the value that gets returned. This does not modify the value x sum. So here, if I call this function sum times 10x, it returns the value 50, but it doesn't modify that value sum, okay? And if I wanted to make use of this value 50, I've got to store it somewhere, right? I've got to store it somewhere. Whereas $sum remains 5, okay? And so, so by choosing your functions to do one or the other, it will help you when you read your code to recognize, okay, here it's returning an object, and you will know it's returning an object because you're going to assign that object somewhere, okay? And then otherwise, you're going to see functions that run, and when they run, you know that they're modifying the object within, right? So if you see this inside your line of code, inside your code, you're going to say, okay, this is modifying a value, okay? When you see this, technically, I should be assigning this somewhere, okay, in order to make use of it, right? Because it's returning a value. And so, value, you know, anytime you're returning a value, you're going to see an assignment operator there as well. Is that okay? Maybe. All right. Okay. This part covers public, private, and active fields. Okay, so if you've done other kinds of object-oriented programming, this is a concept that might be familiar to you, but we're going to introduce it here. This I will not test you on public, private, and active fields. Okay, and you do not need to know public, private, and active fields to complete your homework assignment that's going to use R6. Okay. That said, don't just pack up and leave, okay? So it's useful stuff here, okay? So far, most of our stuff has all just been in the public field. We provided a list of public fields and methods, and that's fine. Public means that you can access those values directly from the outside, okay? And private, on the other hand, are values that exist only inside the object and can only be accessed and modified inside the object, okay? One thing to note is that private does not mean secret, okay? There, you can still, like, if you put information in private, someone else can still find that information. It's not like this secret encrypted thing, okay? It just means these values cannot be modified or accessed from the outside. Okay, so for example, here is our kind of our original definition of person, okay? And inside our definition of person, age and name are inside the public, okay? Are public values. And so here I can say Hadley2 $age is 38, okay? And then I can do this. I can do Hadley2 $age is now 25. And indeed, I can modify that age, and Hadley2's age is now 25, okay? So that, because it's a public value, we can access it directly, and you can modify it and work with it directly, okay? So here, with private, I still have the same initial public functions, but I've moved the fields age and name into private. Okay, we age and name go into private. The other stuff are in public. Okay, and so here we define Hadley 3. Hadley 3 gets defined as Hadley with age 38. Okay, but now when I ask for Hadley 3's age using Hadley 3 $age, it gives me back nothing. It says this thing doesn't exist. Okay, and then if I try to do this, Hadley 3 $age, and assign 25 to it, it returns an error. Okay, you're not allowed to do this with private fields, and therefore Hadley 3, that those values are still there. Age is 38, it's still there, but we can't access it directly. We can't modify it like this. Okay, so this is private. The age values and name values are made private. Over here, they're made public, and we can modify them directly. Is that all right? Okay, and so here is active fields. Okay, active fields look like public fields. Okay, they look like public fields in that you can get a value when you do $, the name of the active field. But, and here's the weird part, or the part that, the hardest part, is that the active field, that value is generated or retrieved, or, it's the result of a function. Whatever value the function returns, that's going to be what you get in the active field. Okay? The functions always are a function of a value. If no value is provided, if the value is missing, then that means the values, somebody is trying to retrieve that value. And if the value is not missing, then that means somebody's trying to modify the value. Okay? So here, we create a class called Rando. Okay? And inside the active list is one field called random. Okay? And here, if the value is missing, which means the value is being asked for, it's going to return RUnif1, one random value from between 0 and 1. Okay? And if somebody's trying to modify the value of random, it returns an error and says you can't set the random. Okay? So this is what it looks like. Okay? Here we create a new instance of the rando object. And just like asking for a public field, we can call x $random. Okay, but the call to x $random produces a random value. This is generated by that function. Calling x $random again calls the function again, and we get a different random value. Okay, so these values are generated by the function. Okay, so when is something like this going to be useful? Okay, well, it's useful if you have private fields, but you want them to behave like public fields. Okay, so when is that, right? So what we can do is, so the example here is we can have a function that will validate inputs before we store them into the private field. Okay, so one issue with a public field is that here I said 25 goes into age, but because it's a public field, I can also just say like, even though initialize did a check to make sure it was a number, there's nothing that prevents me from just putting character values into here, okay, because it's a public field, okay? So here with an active field, I can do some kind of check, okay? So, so here what I do is inside private, I create two fields, .age and .name. So these are the age and name fields, but they're not called age and name. We just put a dot in front of them to kind of just modify them so that they're different, okay? And then the active fields are age and name, okay? And this is what people will interact with, okay? And so let's just look at name, okay? So name, if no value is provided, then that means somebody is asking for the name, and it's going to just return private $.name. Okay, so it's going to pull the value of name inside private. Okay, whereas if the value is not missing, that means somebody is trying to modify the value of name. Okay, then it's going to do a check. It's going to check to see if it's character, check to see if it has a length of 1. And if it passes that, then it takes that value that's provided and stores it into private $.name. Okay, it's going to store that value into private. Okay, sorry, this should be uncommented here. Okay, so just notice what happens here. So here, with this definition, we create a new person, Hadley4. Okay, Hadley4 has the name Hadley, age equals 38. Okay, it looks like this. Okay, so it looks like a public field. I can do Hadley4 $name, and it returns Hadley. What it's doing is that this Hadley is stored inside private. Okay, and then when I ask for Hadley $name, it is going to the active field, okay, and it's pulling name, and it says, well, no value is provided. No one's trying to modify this, so look up private $.name, and it provides that name. So it looks like an active field, but it's not, okay? I mean, it looks like a public field, but it's an active field. And then here, Wickham is provided, and we're going to say store the name Wickham into name, okay? So now a value is being provided, okay? And so when we do function value, this is not missing, and so it's going to check, and it's going to say, is the value character? Yes, it is. Is the value length 1? Yes, it is. So it's going to take value and store it into private.name, okay? And so it allows me to modify this, okay? So it looks a lot like a public field, okay? But here's the difference. When I try to take some value like 10 and I store it into name, this would have been allowed in a public field. In a public field, there's no checks. It just says, okay, you want to change this value, you can change it. But here, because it's an active field, when this value 10 comes along, it goes to this active function. The value is not missing, it's provided, okay? And so it goes through and it says, is character? No, it's not character, so it produces an error, okay? And so here, because I'm using an active field, when I try to change this to 10, it produces an error, and it keeps the name Wickham. Okay. Similarly, you know, the fields for age are active as well. Yeah.
When would we not want to add like a process that checks that?
Yeah. So it's, I guess, laziness. Okay. So I mean, or if you're only going to be interacting from within some kind of structure that you have set up, where you know that everything, all the values you provide are good values, okay? Then you don't have to worry about this, right? But anytime you're gonna allow the user to interact directly with it, then this is probably a good idea, okay? But so, you know, in your homework assignment, I'm gonna have you use R6 objects, okay? You can do the entire thing with public fields and methods, and as long as the code you write is always going to provide good values, then that's fine. We're not going to intentionally try to break your stuff. But yeah, with public things, there's no check. Like, it would allow you to just put 10 into name, and you might not want that to happen. And so an active field looks like a public field, but it runs everything through a function, okay? And so that's what we have there. Okay, we'll end there. I just have one note on S4 and RCN. These are basically the object-oriented systems we didn't cover, and that's that. And we'll see you guys on Friday.